So let's start with binary search. In this algorithm, it works on the basis of divide and conquer rule. In this algorithm, the data should be in sorted manner, that is, in ascending order. Always remember, for binary search, the elements should be present in ascending order. If the middlemost item is matched with the key, the index of this item will be returned. If the middle item is greater than the key value, that is the targeted item, then the sub-array to the left will be searched, and vice versa. Now just remember one thing. Low, which refers to the index 0, and high refers to index number n-1, and middle is 0 plus n-1 divided by 2. I've given this algorithm just for your reference. Before that, let's understand it with an example. Suppose you have been given a pile of books that are arranged in roll number wise, and your roll number is 50. I know that you won't start searching your book from the top. You know that your book will be in this region. So what will you do? You'll divide the books into 2, remove the extra book that is present on top of your book, and take the desired one. So in order to reduce the time complexity which is present in the linear search, we use binary search. Therefore, you can say that time complexity of binary is less than O of n. So for binary search, we know that we have to sort the elements in ascending order, which is very important. But the user has given you in a random way, like 1, 5, 2, 7, 8, 4, 3. These are in random order, right? Now how to assign them in ascending order? Let's see the logic for it. Always remember, the standard way to assign a value in ascending order is by swapping. In swapping, we create a temp variable which stores the element temporarily. Let's take an example of an unordered array which includes 5, 3, 4. Here, I will be starting from 0 and it will go till n-1, and also j will start from index number 0 and will go till n-i-1. Now if loop will be executed, inside the if loop, array of j greater than array of j plus 1. Now what is array of j? Array of j is 5 and array of j plus 1 is 3. Obviously 5 is greater than 3. Now this is true. So it will go inside the loop and execute the statements. Now temp variable will store array of j. Temp variable will store array of j. What is array of j? Array of j is 5. And array of j will store array of j plus 1, which is 3. And array of j plus 1 will store the temporary variable, that is 5. Now, what will be the new array? The new array will be 3, 5, 4. You see how these two elements have been swapped? This is how swapping is being done, and the loop will continue till all the elements are being arranged in the ascending order. Now you know that for binary search, it divides the array by 2. That is, in the first iteration, it will divide the array by n by 2. In the second, it will be n by 2 divided by 2. This will be performed till the elements in the array will be 1. Therefore, now let's try to understand the logic for binary search. First, we will ask the user to enter the key that needs to be searched. We will scan the key value. Let's take an example of a sorted array which is 1, 2, 3, 4, 5, 6, 7. Okay, now the first element will be index 0 and the last element will be n-1. While loop will be executed till the array gets into only one element. Okay, so now it goes into the while loop, and it will observe, it says middle is equal to first plus last divided by 2. Now according to you, what is the middle number for this array? For this array, the middle number will be 4. Now it will check if the middle array is equal to key. Let's say the key value entered by the user is 6. Now obviously 4 is not equal to 6. So it will again go to else if loop. Is array middle less than key? Yes, 4 is less than key. So the code that is present inside the else if loop will be executed. First is equal to middle plus 1. Now the new array that will be is 5, 6 and 7. Why? Now the first will be middle plus 1. Middle plus 1 is 5. So this will be first and last will be 7. Now again the while loop will be executed. Now the middlemost number will be obviously 6. Now is the array of middle equal to key? Yes. Now the condition has been satisfied. Therefore the match will be found and this index value will be returned. This is how binary search works. Now let's try to execute binary search program on code blocks. Just like linear search, I've defined the size of max of an array to 100. I've also defined some variables, and here the new variables are first, last and middle. Before getting into the binary search, we will first sort the array using I and j variable inside the for loop. This is also done by swapping. And then for binary search, we will ask the user to enter the key value that needs to be searched. We will scan the key value and the while loop will be executed till the first becomes last. The middle value will be executed and it checks if the array of middle is equal to key. Now let's try to execute this program and see if it runs. It is asking for size of the array, let's say 4. Now it's asking to enter the elements into the array. I'll give it in an unordered way, 5, 3, 2, 1. Ordered array is 1, 2, 3, 5. Now it's asking for key value that needs to be searched. I'll say 2. Match is found at 2. This is how binary search works. Now let's discuss the time complexity for binary search. After first iteration, the length of the array will be n by 2. After second iteration, it will be n by 2 divided by 2. That is n divided by 2 raised to the power 2. In the third iteration, it will be n divided by 2 raised to the power 3. This is all based on the observation. So after k iterations, the length will be n divided by 2 raised to the power k, right? Let us suppose the length of the array becomes 1 after k iterations. So according to the mathematical expressions, we can say that n is equal to 2 raised to the power k. By taking log on both sides and solving it, we'll get the time complexity as O log of n. Now let us see some of the major differences between binary search and linear search. Input data needs to be sorted in binary search. This is very important, and for linear search, it's not required. Linear search does sequential access, whereas binary search accesses data randomly. You know that for linear search, the compiler checks each and every element in the array. Time complexity for linear search is O of n, whereas time complexity of binary search is O log n. Now you know that for binary search, O log n is less than O of n. Therefore, we can say that time complexity of binary search is less than time complexity of linear search. Linear search performs equality comparisons, whereas for binary search, it performs ordering comparisons. And that's all about linear search and binary search. Please try to attempt these practice questions for more clarification, and I will meet you in the next video.